All right, working on page 1 of your final exam study guide. We are starting with the second half of the year here, so we're looking at characteristics of a graph. So this graph shows arrows at both ends, so your domain on the left side is not bounded, the right side has no boundary, so it's going to be infinite. So we say negative infinity to positive infinity. The range has an up arrow and a down arrow. Again, no breaks anywhere, so that range is also infinite. Where you might see a number in the domain and range would be, so if we had a bottom to this curve, but then it never came back down, so then we would include that number with a bracket. If we had a log graph that had an asymptote running here vertically, then we'd have a domain restriction because it would have a boundary there. You could have a range restriction with a horizontal asymptote. So there are plenty of situations in which there would be a number there. This one's infinite in both directions. All right, relative max. So we're looking for the top of a curve. There's one here. So that's going to be the coordinate 2, 4. And then relative min, we want the bottom of a curve. So that's going to be 0, 0. So when you're doing a relative max and a relative min, you want a coordinate at which the graph turns. So that's where those go. And behavior, we're moving to the right on the first one, positive infinity. So the right arrow is also pointing down. So f of x goes to negative infinity. And the left arrow is pointing up, so that left arrow is going to positive infinity. Okay, increasing intervals. So when we're doing these intervals, let's get our trend markers on. We're moving left to right, so we're moving downward until we get to this turning point, and then we're going back upward. And then we turn around again and go back downward. Right? So the increasing intervals would be this section right in here where the graph is trending up. And the way we talked about this before was that intervals are only concerned with the x-axis. So I really only care about from this turning point on this line here to this turning point on this line here. We're sectioning the graph off into rectangles, so it's only this section in here that would be increasing. That would go from 0 to 2. Don't care about the height at all, just looking left to right. So this increasing interval is from 0 to 2. All right, the decreasing intervals starts on the left. The left would be negative infinity. That up arrow makes no difference at all. It's just a matter of being on the left side. So we have a rectangle over here from the negative infinity to 0. We have another one here. This is going to the right, so that's positive infinity. The down arrow, again, doesn't make any difference. It's just going to the right. So I have two different intervals here. The first one is from negative infinity to 0. We'll join it with a u, and then 2 to infinity. So let's try to get you back in the habit of separating a graph out by drawing those vertical lines in and labeling them so that you don't mistakenly look at the y-axis. Okay. Zeros, we're just looking for x-intercepts for zeros. So that would be one here at 0, 0, and another one here at 3, 0. So you can write them as coordinates. Or you could say that x is equal to 0 and 3. That's another way you could write that. So, okay, what are the zeros of the function? So to do zeros, we need to set the whole function equal to 0. And then we just need to do a solving chart. So anything that has an x in it is going to get solved. So this is just x equals 0. 3x minus 4 equals 0. So x would be 4/3. And here x plus 2 equals 0. So x is negative 2. So we can write that out in order from negative 2 to 0 to 4/3. Okay, simple. Put a 0, do a solving chart. Okay, solve by factoring. Let's see what we got here. It's a trinomial, so we're going to split it into two binomials. X times x. 16 could be 16 times 1, 8 times 2, 4 times 4. Let's do 4 times 4 so we get 8. We want it to be negative though, so negative, negative. And then a solving chart below it. So x minus 4 equals 0, x equals 4. Same thing over here, so that's all I have is x equals 4. Okay, now to get a fourth power, you look for any common factors. There's no GCFs here, so we're just going to go with the double binomial version. And to get a fourth power, I need a square and a square. Okay, and then 42 is going to be 6 times 7, positive 7, negative 6, and that adds up to positive 1. And then I can just do a solving chart from here. So x squared minus 6 equals 0, x squared equals 6, x equals plus and minus, because I'm solving an equation, root 6. Does not split. All right, over here I have x squared plus 7 equals 0. So x squared equals negative 7. And you recall when you do a square root of a negative, you get an I. So put the I before the root. If I could simplify this, I would. And then that simplified number would come in front of the I, but this doesn't go any further. So my answers are plus and minus root 6, plus and minus I root 7. Okay, so just remember when you're solving a square root, you do need to put that plus minus on there. All right, now I have 4 terms, so I want to split those. I want to look at the front half and the back half. The front half, the GCF on this would be x squared, which leaves me with 2x minus 3. The back half, if you have a negative there, let's use it. These both divide by 16. So 2x minus 3. And because these two match, that's going to go first. And then I have x squared minus 16. And from there, it's a solving chart. 2x minus 3 equals 0. X equals 3 halves. And x squared minus 16 equals 0. So x squared equals 16. X equals plus minus 4. Okay, let's go over here one more 4-parter. So I take out an x squared. That leaves me with x plus 2. Here I take out a 5. Leaves me with x plus 2. Common factor goes in front. GCFs go in back. And we do a solving chart. X plus 2 equals 0. X equals negative 2. Squared plus 5 equals 0, so this is going to be negative 5. And so I have an I root 5 after the plus minus. So let's do, and I need to go back and do my set notation there too. We'll do negative 2 plus and minus I root 5. And over here I need to say that x is negative 4, positive 3 halves, positive 4. All right, I'm going to add one problem to this page. See if you can squeeze it in here. Because I'd like to just try a little factoring that doesn't have just x squared in front. So let's add this one in as well. Let's do 3x squared minus 2x plus 16 equals 0. Just in case you come across one with a coefficient in front, you do want to try to divide it first. Doesn't work. So the way we've done these before is we've done slide divide. So it's going to be x squared minus 2x. If I do 3 times 16, I get 48. So now I factor. I need 48, so that's 8 times 6 minus 8 plus 6. And then because I slid the 3, I need to divide the 3. And we'll do bottoms up. So 3 comes in front. And then 6 divided by 3 is 2. So when I solve this, 3x minus 8 equals 0. X would equal 8/3. X plus 2 equals 0. X equals negative 2. Okay, so that gives us a little bit of a reminder about how that factoring could work if we have a front coefficient. And set notation would say negative 2 and 8/3. Okay, so that's page 1 with a little extra. Page 2. So we have synthetic division. You remember that one, that's the one where there is an L shape. And we put the root of the divisor, which would be positive 2, on the outside, so it's just the opposite. and we get all the coefficients represented on the inside. You have to look to make sure nothing got skipped. So there's no missing exponents, so I can just put them next to each other like this. The algorithm goes bring down the first number, multiply the bottom times the outside and put it in the next slot, add the column, and repeat. 7 times 2 goes in the next slot, add the column. 7 times 2 goes in the next slot, add the column. Circle the last number. That's your remainder. So the first number is your coefficient on your first term. First term should be one less exponent than what we started with. So that's going to be 1x squared. The 7 would then be on the next x going down, and this 7 is a constant term. We have a remainder, so plus 16, and we put it over what we divided by. Okay, so that's how we do synthetic division with polynomials. This one's going to be similar. This time I have a negative root. But when I go to write these coefficients, you'll notice there's no x squared in there. So I have a 1 for the x cubed. I need to hold the place with a 0 for x squared, then a minus 17, and then a 32. So just always go back and check to make sure there's nothing missing. 1 comes down. Multiply, add repeatedly until we get to the end. So this last one is negative 40, which means my remainder is negative 8. Again, it was a cube, so my first coefficient represents a square. If this was a fourth, then I'd write a 3 here. So just one lower than whatever you start with. Minus 5x plus 8. And then the minus remainder, and it was x plus 5. Okay. Remainder theorem is the same concept. It is a synthetic division problem. But this time I'm not using a root. I'm just using the number I'm given. And whatever we get for a remainder in this corner will be the answer to f of 5 equals some number. I'm trying to figure out what the answer is when I plug in 5. But we're going to do it using synthetic division. So I'll put a 1 for the cube, a negative 13 for the square, 39 for the x, negative 4 for the constant. Do all the same steps. Bring it down, multiply, add, multiply, add, multiply, add. And then that number is the answer to the problem. All right, function operations. So we're using these three functions. So let's do f plus h first. So I'm going to take 2x plus 5. I'm going to add negative 3x. So 2x plus negative 3x is negative 1x plus 5. That's all it is. Just combine your terms. G minus f. So g minus f says take function g, which is 2x squared minus 7, and subtract function f. And I'm going to keep it in parentheses because I don't want to forget to subtract all the parts. So I have a 2x squared. I have a minus 2x. And then minus 7 minus 5 is minus 12. Okay, g times h. So that's 2x squared minus 7 times negative 3x. So we can distribute this. Be negative 6x cubed plus 21x. Okay, and I think I'd also like to, at this point, try an FOG. So you can add that in too. So that would mean that I do function g being plugged into function f. So function f starts with a 2, but I'm not going to write that x. I'm just going to write the 2, and then switch over to function g. 2x squared minus 7, and then go back to function f and write the rest of that. And just clean it up. So 4x squared here minus 14 plus 5, which would be 4x squared minus 9. So if you're doing an algebraic composition with the open circle there, you just want to start writing the first one and plug in the second one. All right, just thought I'd add that in case that comes up. f plus g of -2. That just tells me that I need to solve f and solve g and add the results. All right, so for f, I'm going to do f of -2 equals 2 times -2 plus 5. And so that's -4 plus 5, which is 1. G of -2 would be 2 times -2 squared minus 7. So -2 squared is positive 4, times 2 is 8, minus 7 is 1. I'm supposed to add the results, so 1 plus 1 equals oh jeez, just wrote -2 there, equals 2. Okay, so if you're given a number, solve each part separately, and then go and write your final answer. G times h of 3, so let's do g of 3 first. So that's 2 times 3 squared minus 7. 3 squared is 9, times 2 is 18, minus 7 is 11. Do h of 3, so that's -3 times 3, which is -9. So if I multiply those answers, it's 11 times -9, which is -99. All right, and then finally FOH, or f of h. H is getting plugged into f, so let's calculate h first. So that's -3 times 5, which is -15. And then we'll use that answer in f. So f of -15 is going to be 2 times -15 plus 5. So -30 plus 5 is -25. So when you have that composition there, solve the inner one first so that you know what to plug into the first one. All right, so that's all of page 2.